We good? We're not good? Don't know the answer? No? Okay, well, get out your notes from yesterday. Put a bunch of stuff down in the life cycle of the star section. Okay? Do you have your texture questions out as well? Yeah, is that what that is?
We'll put it down.
Right.
Thank you.
A bunch of stuff that's gonna help you figure that out. Right now, our sun is at what point in its life? Right now, our sun is in the main sequence. We're in the main sequence. Are there some main sequence stars that are going to turn into black holes? Ooh, that's a question. That should have been my question. Will some main sequence stars turn into black holes eventually? Sure they will. And you know that because what? Some of them are really big. All stars spend some of their life in the main sequence. Remember on the HR diagram, that big swath that goes from top left to bottom right? That is the main sequence, and every star lives in that on that line at some point during their life. Okay, right after they've started to fuse. Okay, right after they start to fuse that hydrogen into helium. So that's where we are. That's where most stars spend a lot of their life. So some stars that are in the main sequence will turn into black holes. Is our star one of those stars that's going to turn into a black hole? No, I see a lot of people shaking their heads this way. No. All right, who haven't I picked on in a while? Let's see. I don't know. Desiree, did you guys talk about this one? Yeah, what did you come up with?
I said no, it's in the middle, it's not a high.
It's not a, I almost heard you, but somebody started talking. It's not a high, what'd you say? It's not a high mass star. That's exactly right. So in order to turn into a black hole, there we go. In order to turn into a black hole, a star needs to have how much mass? How much mass did we say? We said this yesterday, I think. It's a lot, right?
3 or 1.5 something times the star.
Yep, it's 3 times the mass of the sun. If you have a star that's 3 times bigger than the mass of the sun, then yes, it will turn into a black hole. Our star is not that big. What's our star going to turn into?
Black dwarf.
Eventually it will, won't it? Yes. Yeah, can you walk me through it from the main sequence to black dwarf? What's the next step after main sequence? It's going to be a red giant. What's going to happen after it becomes a red giant? There'll be a planetary nebula. Is a planetary nebula the nursery for stars? Is that a stellar nursery? No. It's not. What's a stellar nursery called? Just a plain old nebula, right?
Jerks.
I know. Shake our fist, whatever, we can't do anything about it. But a planetary nebula is just the outside of the red giant being blown off. Okay? Planetary nebula. And then what's left there? A white dwarf. It's giving off light still. It's giving off radiation because photons are still being produced. But eventually, it's going to turn into a black dwarf. Do you remember how big stars can be and still follow this path? How big?
Very big.
1.5 of our sun, right? So our sun and anything up to 1.5 times the mass of our sun. So 1.5 times the mass of our sun, and anything smaller, this will happen. Sometimes the planetary nebula business doesn't happen, but I'm not going to get into that right now. If it's 3 times the mass of the sun, it's going to turn into a black hole. What happens if you have a star that's between 3 or 1.5 and 3 times the size of the sun? What happens then? It's not a black dwarf, and it doesn't turn into a black hole. What does it turn into? A neutron star. Yeah, turns into a neutron star. So if you're between 1.5 to 3 times the mass of the sun, the end state will be a neutron star. We doing all right? We got this. If this stuff seemed pretty straightforward and easy to you, I'm super excited for you. This is the stuff that we go over during the performance task for Unit 2, okay? This is the content that it's focused on. If you read that question, you're like, I don't know, or I needed to look at my notes. Not yikes, that's not fair. Everybody learns at a different pace, right? Some of us take a while to get something, not because we're not smart, but just because it takes a little more time to assimilate, and that is fine. That's why we do this over and over. But you need to own that, you need to know that, and you need to know what you need to study, okay? You all can do this, and you can all be successful at it. You just need to adjust for what you need to do. Okay? All right. I would like for you to get out the dark side of the sun sheet that you had from yesterday. I gave this to you and asked you to do the homework questions on the back for homework. Doesn't happen often. But hopefully you took a few minutes. It was like a 5-minute video to do this. If you did not, Colin. No, I'm just kidding. I'm not trying to call you out. Okay?
Whoops.
Then I'm really sad for you, and I want to make sure that you do watch it. Okay? We're going to go over the pieces because I want to make sure that everybody got the right information. But to be clear, that does not make up for not watching the video. So please, it takes 5 minutes. You had lots of Liberty time yesterday. You get out early today. Find 5 minutes of your life to make it happen. Yes, ma'am. Yes, of course.
You have that sheet right there. I was not here. Where were you? Sick. How do you remember for not bringing
There's my extras. Here you go down here. Anybody else need one? All right. So the first thing that we need to do is to figure out what this set of letters means. There were I heard some conversations in this class and the other class, possibilities of what these 3 letters could stand for. There is one correct answer for our context, okay? We watched a video that talked about CME. What is a CME? Indeed, coronal mass ejection. So we need to break this down. Does anybody know what the corona is? The corona of the sun.
outside? I don't know.
It is also, yes. And that comes from the word from the sun, right? Because, and this is not, I'm not condoning anything, but that beverage is yellow, right? Just like the sun. Yeah. The corona of the sun is anybody want to guess? What's that? Core is a good guess. It's actually the opposite. Good try though. It's like the outside. The outside. Ladies and gentlemen, shh. This is talking about the surface of the sun. Okay. What's mass? What's mass? We've had to define this before. No, that's volume.
Is it the density?
It has to do with the density, I suppose. Yeah, yeah. It's like the hardest one to define. Mass is just stuff, right? It's just stuff. Or we could say matter. What does it mean to eject something? You've watched enough sporting events, perhaps? Or you've, I don't know, seen like those old movies where people are, being ejected from the pilot seat. I don't know. What does it mean? What does it mean, Jacob? You're like, I feel like you have experience with this. I'm hoping not.
No, like in sports.
You watched enough Major League Baseball, I think. Is that what I'm getting from that? What does it mean to be ejected?
You're out of here. Like kicked out. I don't know.
Kicked out, thrown out. You're out of here. Yeah. So now we're going to break this down, you guys. This is how we do this, right? If you're looking at a phrase and you're like, I don't know what this means, it sounds really fancy and technical. Let's look at it. Thrown out, yep. So we've got matter from the surface of the sun that is being thrown out. It's exploding out off of the sun. That's what a CME is, okay? It's a massive solar explosion. Question 2 says, describe the composition of a CME. So it's this explosion. What is coming off of the sun during a CME? What'd you get out of that video? Do you want to talk about that with your table mates first? Yeah? Okay, why don't you discuss all of those questions? So 2 through 5, discuss them real quick and then we'll talk about it. All right. So everybody knows these now. You've had a couple moments to think. Constance, what did you guys say for number 2? Okay, ladies and gentlemen, I'm really sorry. I'm apologizing to Constance for you all. You need to be quiet. Okay? Maybe you didn't realize that we would come back together. If you hadn't, fair enough. We're back together. We're talking together. My friend Constance is going to tell us the answer to number 2, the composition of a CME. What did you say, babe?
It is magnetic arcs that trap solar matter, which is made of super hot gas and electric particles.
Okay, so the composition is going to be that last part that you just said. That is made of, what was that you just said?
Super hot gas and electric particles.
Super hot, really hot gases. And what was the other thing?
Electric particles.
Yeah. When you hear electric particles, you're like, what is that? An electric particle, that really just means that it's a charged particle. Okay? It's got a positive charge or a negative charge. So like all of those hydrogen nuclei that we talked about, those hydrogen protons, that is an electric particle or a charged particle. All right. Question 3. Everybody's had a chance to talk about this, so I hope we all got it. Let's see here. Sydney, what'd you say for number 3?
10 million miles an hour.
10 million miles an hour. Do you guys agree with that? 1 million miles an hour? I have something different written down. But I don't know what the right answer is for sure. You have over 1 million? Over a million? Well, so 10 million would be over 1 million. So you were not inaccurate, right? Let's say over. Is that okay? Over 1 million miles per hour. That's pretty fast, yeah? That's pretty fast. I need to double check that. My key says 1,000. That's a few extra zeros on a million. But if you all heard a million, then I'll go with it. You all heard a million? All right. So I'm going to assume that whoever wrote that key did not put enough zeros in there. All right. If a CME were moving towards Earth, how much time would we have to prepare for the impact? My dear John, I've been asking you questions all day. No, I haven't really. I haven't asked you questions today. Do you have an answer for that one? No. Didn't you have a chance to talk to your partners? I'm going to let you guys talk real quick. Okay? Because I like to pick on you. Because I want to make sure that you get to play with us too. So talk to your table mates real quick. Right now. Help him out, my dears. Help him out. I'm going to ask question 5 while they talk. Guys, shh, 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 shh. Question 5. If a coronal mass ejection hits Earth, how will that affect us, ladies and gentlemen? Elena, what you got?
I said it would melt power grids, blow fuses, and disrupt our communication. It would also wipe out satellites, GPS, and the internet.
That was a lot. Okay, can you say that a little slower?
What?
Tell me, give me the top 3. Read them slowly.
Okay. Melt power grids, blow fuses, and disrupt our communication.
Blow fuses and disrupt communication. Yeah, it would mess things up, you guys. All right, my dear John, did you find out an answer? Did your teammates help you? Awesome. All right, so if a CME was moving towards the Earth, how much time would we have to prepare? Awesome. Thank you so much for your participation. At the long side, right? A couple days at the long side. Go ahead.
I have a question about this.
Yeah, I have an answer maybe.
If it hit Earth, would it only affect like half of the Earth?
It's a good question. So we are going to talk more about that tomorrow. And I'm not trying to skirt the question, but we will talk about it more tomorrow. 100 years ago, yes. But think about how connected we are on the Earth now. Does that make sense? Yeah.
Would it only affect half of the things?
To start, right? So it's going to affect primarily the part of the Earth that's facing the sun at the time, right? When it gets there. But because everything on Earth is so interconnected now, right? With all of the satellites, right? When you get a text message from your friend who's sitting in the next classroom over, it does not literally, I got to make this really clear to you, it does not literally transmit a signal that goes from your phone through the wall to your friend's phone. Do you understand that? It goes up to satellites and bounces around. And so even though, even if you were doing that at 1:00 in the morning, you should be sleeping, but you're texting your friend, I know you do that, right? If that's happening, a satellite somewhere else on Earth or around Earth still could be affected. So it'd still mess up what you're doing. Does that make sense? Yeah. 100 years ago, wouldn't have mattered. It would have mattered, but not nearly as much. Yeah. Did anybody have a different time for this? I think a couple of days was the maximum amount, but it said a few hours to a couple of days. Yep. Awesome. Okay. So this is the result of an active sun. And today what we're going to talk about is, as a solar astrophysicist, that's what you're going to be today, a solar astrophysicist. What in the world does that mean? Solar means that you're studying the sun. Astrophysicist means that you study the stars and study astronomy, and you're looking at the physics behind it. So that's your new title for the day. Okay. As a solar astrophysicist, you're going to take some data that I've got in the form of pictures here and do some analysis of those pictures. Okay. So I'm going to get you some pictures. I'm going to get you some groups, and I'm going to let you do the analysis that is on the front of this sheet. I think it should probably take about 10 or 15, 10 minutes is my guess. Okay. So I'm going to get you started. I'm going to let you answer some questions, and then we will regroup to take some notes. How about your star notes? Because that's where we're going to write all this stuff down. We have spent most of this unit, ladies and gentlemen, just talking in general about how stars work, how they ignite, how they go through their life cycle, and how they end up in the end, how they meet their demise. But this particular thing, and then the thing we're going to do tomorrow, is focused on how the sun affects us. So my question for you, my first question is the sun good for us? What does the sun give us? It does. Yeah. The sun, so this is going to go in your notes, the last section. I just didn't have another printout of it. So under sun's effect on Earth, that's what it says in your notes, right? Yeah, so under sun's effect on Earth, we're going to say that the sun provides light. I just heard somebody say it provides heat. It provides energy. Really, all of those things go together, right? And it provides that light, heat, and energy to all of the Earth's systems. Starting in Unit 4, instead of focusing on the space science, we're going to be focusing more on the Earth science. But the thing that I want you to remember is that all of that comes from the sun, and without the sun, we would have none of that. The Earth systems, including, I'm just going to throw out some fancy words here, including the biosphere, which is all of life, including the hydrosphere, what do you think the hydrosphere is? The water on the Earth, right? Including, those only two that we have on that they had in the list. Sorry. Okay, that light and heat and energy drives all of the weather patterns on Earth. Okay, it drives the ocean currents. And it's funny, being here in Iowa, sometimes we don't think that the ocean affects us. It actually really does quite a bit. It's kind of surprising. We'll talk about that. And the water cycle. Without the sun, none of that would happen. It's not just that our plants wouldn't grow, but it would not rain and precipitate in the way that it normally does. Okay? Those are good things that the sun provides. But there are also, and this is the piece that we're going to talk about a little bit tomorrow also, there are also negative effects. Okay? The things that you looked at on those pictures, those dots on the sun, what are they called? Sunspots. And solar flares, okay, can lead to power outages. This is the stuff you told me earlier. A loss of satellites, we'll look at that tomorrow, that graph. We'll look at that tomorrow. A loss of communication. And would really change pretty much the entire way that we exist. Which is kind of a scary thought. We're going to stop there. We'll do a little more with this tomorrow, okay? Have a fantastic day, you guys. I hope that your Thursday is awesome.